member of the OpenSUSE team, actually, and I'm talking today about a tool mostly used for OpenSUSE so far called KIWI. It's for creating system images. So, yeah, what is KIWI? I also gave a short explanation. First of all, it's a command line tool, so it's fully integrated promo CDs or DVDs that are fully runnable without installation on your system. In the meanwhile, it's also possible to create the installation repositories, so the regular SUSE DVDs with it. And maybe you've heard of the SUSE Studio. This is an appliance creation tool, web-based. A colleague of mine will later have a talk about it. And yeah, it's the backend for it. And there's also a YAST, maybe you know YAST or a system configuration tool, a YAST graphical user interface for it available, so you can, if you don't want to use command line tools, you can have a graphical version of it. So what is an image? It's not like this one. It's more or less these kind of images. KIWI supports creation of all these types of system images. I also already mentioned the live CD or DVD. Same from booting from USB sticks or USB hard drives. You can also have an OEM hard disk image. Means you can have simply a big hard disk image to simply DD on a hard drive, and you can mount it to a computer and everything will be running. Same for network bootable images, PXE, for example. Virtual machine images like QEMU and VMware are supported. Also for Zen and this EC2 Amazon stuff. So what are used? How are these images useful for you? Maybe, for example, if you want to distribute your software, maybe you have an open source project or even a proprietary project running on Linux, so you can create a, for example, DVD with your software already installed and pre-configured. Simply distribute it, and your customers or your users can evaluate your software. You can actually pre-configure everything, so it's running out of the box. You can create rescue systems, for example, USB stick where you can boot from to restore your maybe backups from elsewhere. And yeah, as I already mentioned, to pre-install a Linux system on many machines. For example, if you're a system administrator and have a computer pool, maybe at a university with 20 or 30 machines, all the same, or maybe even not the same, simply DD an image on it and you have a running system. So, I will show you on a short example how to use KIWI. It basically needs only 3 steps till you have your image ready. First of all, you have to create a description, means a configuration file where you describe what you want to have on your image. Then you run KIWI to prepare the file system tree. So it's more or less the same as your running system. And the step 3 is create the image in the type I described before. So if you want to have a ISO or hard disk image or whatever. And you don't have, if you want to have more than one image type, you only have to prepare it once. So you can create more images from it. So, short explanation about the first step. It's more or less simply a directory where you put all the stuff you need for your image in it. And this is basically an XML file that contains, for example, a package list and maybe some services you need for your image. And some optional stuff. You can do manipulations of your image on different stages during the build process, I will explain. It can also contain simply files that you want to have on the image and that maybe are not packaged into a RPM package or Debian package, for example. There are also files that you maybe do not have in your running system, but only in the distribution media. For example, on an installation CD, you have licensing files or something in the root tree, but you will not have them in the system you have running afterwards. And in the OpenSUSE case, for this just2 first boot configuration, if you will use this just2 first boot tool to do configurations on the running system on the first boot. So if your customer is booting your image, then you maybe have different audio hardware than you have. just2 first boot will do that for you. So usually it's a bit boring to show huge configuration files in a presentation. However, for this example, that is, by the way, included in the documentation of KIWI, not only this one, there are many different use cases included. It only needs about 40 lines of description to have a OpenSUSE live ISO image prepared. And these are basically these 40 lines. Everything is contained in an image container, and for example, you have some meta description for it. The author is the original author of KIWI's Michael Schäfer. I'm doing the presentation on this one. Describe your image, give it a name, and yeah, you also can have a longer explanation for it. It's not included here. Then you have, of course, preferences of your system. So different image types have different settings. So in this case, we only have the image type ISO included. So that is the already prepared and in KIWI included boot image. You can give it a version. You can use different package managers. In this case, we are using the SUSE tool Zipper to install all the RPM packages. You can also use Smart for that. That supports, as you maybe know, also non-RPM distributions, or at least Debian. Some other configurations, for example, the key table to make it fit for the keyboard you expect to be using. You can define users. In this case, we only have a root user. You can prepare the password for this user in an encrypted, hashed way. You can, of course, also have as regular users pre-configured. The most differences between all these images will be the software that is installed on them. So we have, first of all, you have to define a system repository where all your program packages are stored before the installation. In this case, we are using this is a shortcut for OpenSUSE, for the OpenSUSE installation repositories online. It's basically an installation over HTTP. This OpenSUSE part only shortens the URL a bit. And as you can see, we have the Elementor 2 repository where all the packages for the installation of the image will be. You can also use local file systems. Maybe you have a local DVD with all the RPMs on it, or you have a downloaded already these three. There's also file and local directories actually. The next part is you select the packages you want to install, and there are basically three types of, well, yeah, in this case there's only two types of packages. This is a pattern. This is something that is specifically for OpenSUSE. That is because it's that's the reason why it is prefixed by OpenSUSE. We have so-called patterns, and the default pattern means that is the minimal system you need to have a running OpenSUSE. So it's actually a collection of packages. And you can select additional packages. For example, this package Vim, if you want to have an editor on this. And if you want to have, you can manipulate where the packages are, where you need them. For example, in this case, you need it in the boot system, because it's the boot / branding, so that your image is starting already with an OpenSUSE graphics. So that's all for the config XML file. There are also some shell scripts. In this case, you only need this config sh that does, after all the packages are installed in this change root environment, it is actually used by change root. You need a script. You can do anything you can do in a shell script, so you can manipulate files. You can, for example, in this case, I'm talking about this OpenSUSE image, there are some services enabled. The run level that is used for booting up, so boots in this case up to run level 3 only, I think, because it's a basic system. And also a SUSE specific part, you're running OpenSUSE config to do the system configuration with it. That is fully configurable, so if you don't want to use the SUSE system, don't run OpenSUSE SUSE config, for example. So after we created the configuration for our system, the actual file system tree is built up, and this is what, how or when KIWI appears first in this thing. You only need these two parameters. Prepare means we are calling it in the prepare step. Yes, the third step is a different parameter. You need a directory for that, where to store all the packages. Not the packages, where to store the image. And, oh, sorry, mix it up. Here's the description we have prepared before, and the root is, of course, the root image, where to put all the data. And this call is running for a while, and because it's created a full root tree, it is usually where you can also, after it is finally prepared, can change root and do manipulations in it. And this root tree is then the base for the next step I will show. If you want to create more than one image type, not only an ISO image, maybe also a USB image, then this step you have to be done only once. Then you have this, basically your setup, and create more images afterwards. Yeah. So the third step, create the image, called KIWI create, with the root path from the call before, the type you want to have, because you can, of course, configure more than one type, as I already told in the description file. In this case, we want the ISO image, and the destination directory where to put these ISO images. And after that, it also takes a while. You have a ready image that you can use. You can, for example, check it first with VMware or QEMU if you have an ISO image, for example, and your pre-configured image is ready. It's actually as easy as I described it here. So, so far we were also only talking about the SUSE way, because KIWI is so far prepared only for OpenSUSE, but it is, as I can show you here. As I already said, not only Super is usable, but only Smart. So you can so far already build up the file system tree with, for example, Fedora or Debian packages. And because the design is quite independent, all the distribution-specific stuff is stored into special functions that are in the moment prefixed by, the name of them is prefixed by SUSE or OpenSUSE. So to enhance KIWI for really do Fedora or Debian or whatever images is create modules with the appropriate prefix to do mostly the bootloader configuration. That is definitely different than SUSE. For example, also init.rt, which is mostly the boot stuff is different in different distributions. And of course the system configuration, because Yast is usually not available on other distributions. Yeah, and after these steps are done, I think it should be easy to do these other distribution images with it. And so I can only say, please contribute if you are interested in building system images and you may be familiar with other distributions. If you are able to program in Perl, then you will have it easy, because KIWI is completely written in Perl. Only some parts are, of course, shell scripts. And it is open source and free software because it's licensed with GPL. And to contribute, you can simply check out it on the Git repository on Berlioz.de. So, if you want to find out more about KIWI, there are two websites: the project webpage on Berlioz.de, and of course in the OpenSUSE wiki, where you can find some more use cases. There are also already people that did some projects with it. They mostly have done descriptions of what they did and wrote it down in the wiki. You'll find more examples and a quite good documentation. I have it printed here. It's a KIWI cookbook where you can quite easily create some types of images step by step explained. And if you want to install it via RPM, you can find them in the OpenSUSE build service in the project virtualization appliances. Yeah, and I think I was quite fast, so I already am finished with my talk. So if you have questions, just ask them now.
So at the moment, only OpenSUSE is fully supported.
Yeah, but it is, of course, it is designed platform independent or distribution independent. So basically, you only need
everything's possible.
Yeah.
For the future.
If that is only the specific parts I and Marcus are not aware of, that's a difference between these different distributions. I don't know how to set up Red Hat system, for example. So if you are able to do that, you can implement it, and it should be easy to do that. Yeah.
I think the main problem is that the other distributions already have their own infrastructure set up for things like that. Debian has its tools for building live CDs and even installation CDs or DVDs or other images. We got the same in Fedora, so there's no real need to adapt a tool from another distribution, which maybe don't fit enough, or you have to put quite a lot of effort into it to allow builds on other distributions. So the question is, does it have a real benefit in comparison with the tools other distributions already had for quite a while, even before KIWI has been started? The only benefit I personally see is the usage of SUSE Studio to build other distributions, because this is a unique project. I don't know a distribution who already has a similar infrastructure. It's really cool. If you could manage to implement a build system for other distributions out of Studio, this would be a great effort for everyone.
So basically, to do that, it would be necessary to make it possible to create images from other. Because in the build service, we already are able to build packages actually for other distributions, and since it is quite based on a build service.
Yeah, but I've tried to build Fedora packages with the OpenSUSE build service, and it's not quite usable as the tools we use within our distribution.
So basically, you need a spec file.
We simply come together and sit down for a while and talk about it, and maybe we'll find a way to improve it to make this happen.
I think the main thing that differentiates KIWI from all the other distribution scripts that are there to build live CDs is that it is not distribution specific. So you have a tool that everybody can use. Of course, it would need adoption.
Yeah, in theory, but you have to put quite a lot of effort into it to make it happen, that it will be able to build other distributions.
Right.
I'm not sure how hard it will be to implement, for example.
I mean,
I don't think it's too hard, because you have these, as you already mentioned, there are scripts doing Fedora images, for example. And I think you're more or less doing the same. So you could snip out the specific parts and plug it into KIWI somehow. So, yeah.
I see a serious advantage, no matter if it's KIWI or something else, if you have one description and you just rerun it and you get it for.
Yeah, but the problem is in history, because every distribution already had their tools and nobody came together, and I definitely like the approach to keep it open by design. Definitely. The same example is Mirrorbring. It's open by design, it's a cool project.
But it's not only just about building distribution images. I know from a customer who wants to go this way for building his appliance, adding his own code to a distribution. And right now he runs on different generations on SUSE. He wants to just package his application, all this stuff for different appliances and things like that. But the big idea on them is also they want to have one description for all their setup and their hardware drivers, a lot of stuff involved and client server stuff and things like that. And if they don't want to like, or if a customer asks, oh, we don't want to like this box running SUSE Linux or whatever, then they just replace the part, oh, take this distribution, we make that, and that didn't happen yet, but at least it works with different versions of SUSE Linux. And it would be really great if now that more and more visualization is coming, maybe it's another topic. If someone asks, I have to have this appliance for my system administration stuff running Fedora, Debian based, whatever, then it would be much easier to package all the stuff I want to ship and sell, that flavor and this flavor and things like that, and having a generic tool which does all of this would be really nice. And since it's scripted, I have looked a little bit into it and didn't try yet to adjust these things, just fix other bugs, and should be doable.
One question about the framework is the studio part. Is it already open sourced now, or is it still internal Is it available?
It is available, but I think it's not really open source, the studio part.
Okay, but you're planning to make it open source, or does Novel plan to make it open source? Do you know anything?
That's maybe you can ask in the build service talk later, because I'm not involved in the build service actually. In the build service, and then in the studio talk later. I'm not involved in the studio team.
You mentioned OpenSUSE. Can I also use it for Slack?
Yeah, definitely, because it's basically the same. You only have to define the repository for the Slash packages, and the configuration is nearly the same.
They're just cheap OpenSUSE knockoffs.
Yeah.
Some people are like it.
Yeah.
Do you know of real-world uses of KIWI? What are people doing with it?
On the in the wiki, there are some use cases. People actually using it. The SUSE Studio, for example, ships an appliance system image to do in-house, that customers can do in-house image creation with it. So it is basically its own customer. Yeah.
So what about if you concentrate on SUSE, what about the debrand or rebrand process? Is it already implemented in KIWI right now? Because I know we talked about for a year or so back, because it's not allowed to rebuild a SUSE-based distribution and spread it if it still contains the SUSE signs. Is it already implemented?
I'm not sure about that.
Well, there is a simple, I mean, that's rights or law stuff. So there's a simple way of just requesting permissions to distribute that stuff. And there's a tool called Rembrandt, which is...
Yeah, but typically the tool has also all branded stuff split it out into packages. So you see those
simply the choice not to install these packages that are branded. It's nothing related to KIWI.
From another build service source or something like that. I guess you can split that, yeah? Or you have to set up your own build service source from which you build, which only contains packages being rebranded or something like that.
You simply don't have to use all the branded packages are separate packages.
Yeah, of course, but they are dependencies from other packages. I don't think that you can simply remove them.
Oh, you can.
I think.
Oh, okay.
So
there's the main package, then is the dash branding, dash upstream that contains the upstream branding. Then there's dash OpenSUSE and dash slash or whatever.
That is, for example, this Foodsplash branding package that is included here separately. That's the reason why it is there. Yo. Other questions? We still have what an hour.
So you mentioned that it can create live CD images and basically.
Yeah.
Is there any thoughts of support for it creating an installer image?
Yeah, I did not describe that. You can also create the, or actually the 11.3 images that will be released in, I think, 3 months or something like that, will be created with KIWI. So installation sources are also possible in the meanwhile.
Actually, the one was already created.
Actually? Okay, it's only /11 SP1 that is currently, okay, doesn't matter. It works. And that's actually the part I am working on.
Do you ship this XML configuration files as example? I don't think
Yeah.
they are included, yeah?
That are included in user share packages KIWI.
Oh.
They are, I don't think I have them on this computer, but even 11.1 to, no, 11.0 to 2. And not only live ISO images, also live USB sticks, and a lot of configuration is there.
And for the installation images too? Yeah?
Not for the installation
Yeah.
images, only for the live images.
Exactly.
But
Yeah.
you can check out the installation, which is description from the server.
Okay.
Okay, yeah. And how to build them is described perfectly in the documentation. I'm really happy about this documentation, I think.
You have written it, I guess.
No, it's written by the original author, Markus Schäfer. Yeah. So, thanks a lot. If you're interested in use the web pages, they are really useful, actually. So, thanks.